Okay, we're going to take a look at circles, the first of the conic sections that we're going to take a look at. And basically what we want to get out of this is understand how the center, the radius, and the equation of the circle all work together. They all fit into that equation. Um, so far this year we've looked at lots of different functions. So we've looked at linear functions, we looked at polynomial functions, we looked at quadratic functions, which were polynomial functions of degree 2. We also looked at rational functions, although we didn't go into a lot of detail with those, but we did briefly discuss them. So we spent a lot of time talking about functions, which way at the beginning of the year we defined a function, and I've just kind of been working with them ever since. And so just to remind you, a function is a set of ordered pairs where every x value is paired with exactly one y value. Now, we don't always use x and y as the variables, so another way to think of it is it's a set of ordered pairs where every element in the domain is paired with exactly one element in the range. And then that would work regardless of the variables used. So what we're going to do now is we're going to take a break from just looking at functions and only functions, and we're going to take a close look at our first non-function, and that would be the circle. So a circle, its definition, this is more of an algebraic definition since some of you guys have not had geometry yet. So it's the set of all ordered pairs in the coordinate plane that are a fixed distance called the radius from a fixed point called the center. So I've got my crude picture down here. By no means is this a perfectly drawn circle, so feel free to make fun of it. We got our y-axis, our x-axis, so we're on the coordinate plane. We've got a point called the center, and then we've got this distance of r called the radius. And what the definition is saying to you is every single coordinate xy that's exactly this distance r away from the center makes up the circle. So if I go from the center to any coordinate on this circle that I've drawn, I will be exactly a distance of r away from that center. And what you end up with, when you put all those points together, you end up with a circle. So algebraically, we want to work with the standard form of a circle. So this is the equation of a circle in standard form. It's the quantity x minus h squared plus the quantity y minus k squared equals the radius squared. So the center of a circle will be whatever h is and whatever k is. So it'll be h comma k. H is the number that is with the x in the parentheses, and k is the number that's with the y in parentheses. And it works a lot like our vertex form for a parabola that we just recently studied, where it's minus h and minus k. So when you're looking at the equation, it'll be the opposite sign of what's sitting in the parentheses. And I'll remind you that when we look at some examples here in a second. And then it equals the radius squared. So the radius is just r, but in the equation it'll be squared. Something else we got to kind of keep track of when we're working with these. So we just want to get comfortable with this equation and how the center and the radius play into it, how to graph a circle, just some basic stuff with circles that we can do algebraically. So first up, let's write the equation of a circle that has a center of -2, 5, and a radius 3, and then we're going to graph it. So they told us that its center is -2, 5, and that's important because -2 is h, and then the 5 is k. They also told us that its radius is 3. Well, the radius, that's r for the equation. So standard form is x minus h quantity squared plus y minus k quantity squared equals the radius squared. So let's plug in what we know. We know h is negative 2, so we'll have x minus negative 2 quantity squared plus y minus k quantity squared equals the radius squared. So we plug in our there's our h. We plug in k, there's k, and then we plug in the radius right there. So they just get dropped in right where h, k, and r are located in the equation, and then we simplify. So it ends up being x plus 2 quantity squared plus y minus 5 quantity squared equals 9. So the h and k, notice that when you write it as a coordinate, they'll be the opposite sign than they are in the equation. So it's x plus 2, but it's negative 2 in the coordinate. Y minus 5, but it's positive 5 in the coordinate. It's very similar to what we had to deal with when we were using vertex form of a parabola, of a quadratic. So there's the equation. There's the equation. Now, let's go ahead and graph that. And it kind of seems like it'd be complicated to graph a circle, but not really. If you just know the center and the radius, graphing it's not too bad. So let's go ahead and get a coordinate plane. This will be the y-axis. This will be the x-axis. Our center is negative 2, positive 5. And then our radius is 3. So a quick way to graph this is just go 3 below, above, left, and right. So just go down 3, to the right 3, 3 above, and 3 to the left. Just go 3 north, south, east, and west. And then do your best to draw a decently shaped circle. It doesn't have to be perfect, but it should be, look like you put some effort into drawing a circle. So just remember the center is not actually part of the graph. So like what I've got in blue here is the circle. The center just helps me graph the circle. Okay, so one of the things I want you to notice is that this is not a function. This does not meet the definition of a function. It fails the vertical line test. If you draw a vertical line, it hits the graph twice. So it fails the vertical line test, so it's not a function. Specifically, you can see that it's not a function by plugging in an x value. So let's say I plug in negative 2. So say I plug in this x value right here, negative 2. So let's let x equal negative 2. So then if I plug that into the equation, I get negative 2 plus 2 squared plus y minus 5 squared equals 9. Well, this ends up being 0, so I'll just take the square root of both sides. Principal square root. I get absolute value of y minus 5. Principal square root of 9 is 3. So I get y minus 5 equals 3, or y equals 8. And I also get the opposite of y minus 5 equals 3. So y equals 2. So I end up getting two coordinates. I end up getting the coordinate negative 2, positive 8, which is right here. And I end up getting the coordinate negative 2, positive 2, which is right here. So what I'm trying to show you here is this one x value of negative 2, it's paired with two different y values. So it's not a function. So this is the first non-function that we're actually going to work quite a bit with, more than we have with anything else that wasn't a function. All right, so what if you have an equation that looks like this? It doesn't really look anything like a circle, but maybe you suspect it is a circle. So how could you tell? So how would we know if something that looks like this, it's got x squareds, x's, y's, some constants, how would we know if this is a circle or not? So um, back when we learned quadratics, we learned how to complete the square, and we're going to use that again. So our good friend completing the square is going to step in and help us figure out whether this is a circle or not. So the first thing we want to do is we want to collect all of the terms that have an x. We want to put those together. And then we want to take all the terms that have a y. We want to put those together. And then let's go ahead and move anything that's a constant to the other side, just to kind of get it out of our way. So I didn't do anything fancy. All I did was move the 10x over next to the x squared, and I moved the negative 4y next to the y squared, and then I just moved the 21 to the other side of the equation. So I just subtracted 21 from both sides. Now I did that because if you look, I now have x squared plus 10x and y squared minus 4y. So what I'm going to do is I'm going to complete the square on both of those separately. So let's do the x's first. So there's a 1 out front, just like there's a 1 out front here. And to complete the square, we'll just take this 10. We'll just take this 10. We'll divide it by 2 and square it. So we'll take that 10, we'll divide by 2 and square it to get 25. So we add our 25, and then there's nothing that comes after it because the y squared and the negative 4y, we're going to deal with that separately. So there's nothing really that comes after it, so we don't have to bring anything down. But then we need to subtract the number out front times the number we just got. So we need to just like when we completed the square. And then this should factor. So we get x plus 5 quantity squared and then minus 25. But we also want to do this with the terms that have a y in them. So we're going to do the same thing with the y terms. So it'll be plus 1, and then it'll be y squared minus 4y. We're going to take this negative 4, we're going to divide it by 2, which would be negative 2, and square it to get 4. And then we're going to do minus the number out front times that 4. And then don't forget, on the other side, we had that negative 21. It's easy to forget about this negative 21 that's just hanging out, minding its own business. So now this should factor, so it'll be plus y minus 2 quantity squared minus 4 equals negative 21. So collect like terms, the negative 25 and the negative 4, that's negative 29. And then go ahead and add that to the other side. And we end up with 8, which that's the equation for a circle. So we've got center. Our center is negative 5, positive 2. And our radius is, remember, this is r squared. So this is not the radius. So this is r squared right here. So r squared is 8, which tells me the radius, after you square root both sides, the radius will be positive or negative square root of 8, which we can simplify that. So our center is negative 5, positive 2, and our radius, all right, so you got to remember the radius is a distance, it's a length. Well, distance and length can't be negative. So it's just going to be the positive, and then when you simplify square root of 8, principal square root of 8, you get 2 root 2. So yes, this equation did represent a circle, and the circle has a center of negative 5, 2, and a radius that's 2 times the principal square root of 2 units in length. Let's try that again. So let's see if this one represents a circle or not. So let's go ahead and put all the terms that have an x together. Let's put all the terms that have a y together. Let's move the constant to the other side so it's not in the way. And then we'll complete the square. So we take negative 8 divided by 2, get negative 4. Squared is 16. And then we do our subtraction. And then for the y's, we've got y squared plus 6y. We take 6 divided by 2, which is 3. Square it, and you get 9. Then we got to do our subtraction. Don't forget about the negative 30 that's on the other side. This will factor into x minus 4 quantity squared. This will factor into y plus 3 quantity squared. Go ahead and collect like terms and get negative 25. And then go ahead and add 25 to both sides and get negative 5. So when you look at this, you think, all right, that looks like a circle to me. So the center looks to be like it's going to be 4, negative 3. But then when you go to do the radius, well, r squared is negative 5, which means r would be positive or negative I principal root of 5, an imaginary number. Well, the radius is supposed to be a length, and an imaginary number does not represent any sort of length on the coordinate plane. So what that's telling us is this must not have been a circle, because on the right-hand side, we should have a positive number that represents the radius's length squared. And we don't have that. We have an imaginary number. So this is not a circle. It's not a circle because the radius is an imaginary number. The length is, what should be the radius ends up being an imaginary number, which is not a length. So there is no center because this isn't a circle, and there is no radius. So this is just not a circle. Even though it kind of looks like one, it's not. All right, some of you guys haven't had geometry, so real quick, a little bit of vocab here. We say that a circle is tangent to a line if the circle and the line intersect at only one point. So I've drawn an example. So I've got this circle. Again, it's not a perfect circle, so feel free to make fun of it. It's got a center right here. There's its radius, r. I've got this line that comes by, and it intersects the circle at one point and one point only. We call that the point of tangency. So it's the point where the circle and the line intersect. Now remember, a line goes on forever in all directions. So you could call that and say it's tangent, because the line will keep going and end up hitting the circle later on. So now it's intersected it twice. So that wouldn't be a line that's tangent to the circle. So it's got to be something similar to what I've drawn here. All right, so let's say we're charged with finding an equation of a circle with radius 3 that has its center in quadrant 1 and is tangent to the y-axis at 0, 2. So draw a picture. So if I draw a picture, here's the y-axis, here's the x-axis. We know the radius is 3. Its center is somewhere in quadrant 1, so it's somewhere in this quadrant. It's tangent to the y-axis at 0, 2. So this is the coordinate that the circle and the line both share. And that line is the y-axis. So there's the line that's intersecting the circle right here. So the circle contains this point. Well, the circle, it has to have its center in quadrant 1. So that means my circle has to look something like this. Well, it'd be nice if we knew where its center was. Well, we do know where its center is because its radius is 3. So I can just go 1, 2, 3, and there's its center. So right there's the center. So its center is 1, 2, 3, positive 2. So my equation should be x minus 3 quantity squared plus y minus 2 quantity squared equals the radius squared. So x minus 3 squared plus y minus 2 squared equals 9. That's the equation of the circle that they've described. And if you want to see the entire circle, 1, 2, 1, 2, 3, we can now draw it. Now that we know everything we need to know about the circle. So our circle's right here. Looks something like that. It's, again, not a very well-drawn circle, but gets the job done. Okay, so we've practiced working with that equation. There's not a lot to it. There's just a few things you got to be careful of. So the last thing we're going to do is, where did that equation come from? Nothing in mathematics just falls from the sky. So where's that equation come from? Well, um, it's actually pretty simple to show compared to some other derivations and proofs. It's actually pretty simple to see where it comes from. So let's say you have some center. So let's say this is the center, what is called HK. So we don't know where it is. It's at some x coordinate h and at some y coordinate k. And let's say it's got a radius of r. So its radius r. So its radius is r. So we end up with, this circle. So we've got this circle. So we've got this circle now. Now the only thing we really know about this circle is that the distance from the center to any coordinate on the circle is r. Well, earlier we learned what the distance formula was. So we said if I want to find the distance between 2 points, if I want to find the distance between hk and xy, that distance is the principal square root. We subtract the x coordinates and square them. We subtract the y coordinates and square them. And then that equals our distance. But for this circle, according to the definition, that distance is r. And then we can, if we want, we can get rid of our square root, our radical, by squaring both sides. So if I square both sides, I end up with the standard form for a circle.